Hi, this is Mrs. Jones, and we are going to go over the study guide for the Systems of Equations test. All right, here we go. The first type we're going to go over is when you are solving a systems of equations by graphing. And here we have two equations, and so you want to graph both of them on one coordinate plane. And the whole point is to find that point where the two lines intersect. So to graph them, for the first equation, you're going to want to graph your y-intercept, the 2, which is on the pink line, and then your slope is 4. So you go up 4 over 1, or you can go down 4 back 1. You make your line. For the other equation, once again, you always start at the y-intercept, which is the 6. And it has some negative slope, so that means over time the line should go down. So you're going to go down 2 over 1, down 2 over 1. Okay, we graphed our lines. If you see the point where these two lines intersect is not exactly where an x and a y meet, and that's why it asks you here for the estimated solution. So the estimated solution would be approximately where does it meet. And I just put an approximation. It's not exactly where it is, but just to kind of give an idea, if you start at the origin, you don't go over one full, you just go up over part of the way and then it's up above the 4. So that's where I approximately got it. Well, then part B tells me to solve for the system algebraically. So I did that. Well, the first step is always to isolate a variable. Well, we already have a variable isolated here because we do have the y by itself. So then I went to step 2, substitution. And that means basically in this equation, I'm going to substitute this y with what y is equal to. So I'm going to substitute this in place of y. And that gives me this equation. 4x plus 2 equals a negative 2x plus 2. So this side is equal to that side. I used the steps for solving a multi-step equation. Got all of my variables on the same side. Started to move all of my numbers, divided. And then from here to here, I just, from the 4/6, I simplified it by dividing the top and the bottom by 2, and that gave me 2/3. So that's x. To get y, you have to substitute once again, and that's what I did over here. And you are working with a fraction. So you are going to be allowed to use your calculator with working with these fractions. And you will see that you substitute in a 2/3. When you multiply this, you multiply 4 times the top. 4 times 2 would give you 8 over 3. And then when I added these, I had to find a common denominator. And then I was able to add them and to simplify. And that gave me 4 1/3. Okay, let's go to the next problem. All right, this one says, let's see if we can get it into focus here. There we go. Which of these systems of equations has infinitely many solutions? And that means that the two equations are going to be exactly the same. So if you look at answer A, we have an equation on the top, y equals a negative 2x plus 7. And then we have this equation on the bottom that goes with it. So what I did over here in the pink is I took that equation and I changed it into slope and intercept form, which has 2 steps to it. Move the mx by adding or subtracting, and then divide by what's with the y. And that ended up giving me the exact same equation I had here. So your answer is A. I did go through, though, to make sure I was correct, and I changed this problem into slope-intercept form. I moved the mx and divided by what's with the y. For C, I did the same thing for this equation. I just had to move the mx. And so that gave me the same slope, but different y-intercepts. And then here I did the same thing here. So the only one that had two equations that were exactly the same, which made it infinitely many, was answer A. Okay, let's go to the next page of the study guide. All right, here you were to match one of these equations on the top with a graph. And this is a wonderful example of when you have to watch your positives and your negative signs, because I made a mistake my first time and I had to go back and fix it. In each of these, you want to change them into slope-intercept form, like over here I did, where you want to move the mx to the other side by using inverse operation, adding or subtracting, and then you divide by what's with the y. Did that there and here, and that gives you your equation in slope-intercept form. Well, then you want to match it with a graph. So for example, this one has a y-intercept that is from a -4. So that tells me it has to be either this graph or it has to be that one, because they both have a y-intercept at the -4. It has a positive slope, so that tells me it has to be this one. So I went back to the original equation and then I wrote it in here. And that's what I did for all of these problems. So on the test, what we're going to do is we'll have, like, this is B, C, excuse me, A, B, C, and D, and then you'll match on the letters with the graphs. And then over here, I took these equations and did the same thing. I moved the mx by using inverse operations, divided by what's with the y, and then I simplified this one, and then I divided that out. Same thing here. And then these are the answers. So basically, A, this equation is here. B, the 4x minus 2y is here. 2x plus 4y equals a -8 is here. And then this one was the last one, D. Okay, here's another one with graphing. And once again, you have your two equations. And so you take those two equations and you graph them. You start with the y-intercept. From there, you graph the slope. Always look, if you have a positive slope, then your line over time should go up. So it's the one in pink. This one has a negative slope, so it's this line in orange. It goes down. Okay, this point where your lines intersect, that is your answer. And it is at the 1,5, because from the origin you go over 1 and up 5 to get there. And it says describe the graph of the system and how it relates to the number of solutions. And I put there is one solution where the lines intersect. Okay, for problem 8, you had to match. It says sort the systems of equations into the appropriate bins that describe their solution. So these two problems have different slopes, different constants, and so, the coefficients, excuse me. So they are going to go into a solution, different slopes. If they are exactly the same, like this one is going to end up being, when you do the distributive, then that means infinitely many, because they're exactly the same. And this one, when you do the distributive, you end up with y equals 5x minus 30. So you have the same slope, but you have different y-intercepts. That makes parallel lines, which would be no solution. Okay, let's go to the next one, the number 9. Okay, it says one equation in a system of equations is y equals 2/3 x minus 5. For which second equation would the system have exactly one solution? One solution means they have different slopes. So this slope in this equation is 2/3, and the slope's always in front of the x. So you want to find out of these equations which ones do not have 2/3 as a slope. And that would be A and B. Here, when you divide everything by 3, then you do get the same slope. Here, you divide everything by 2, because you want to isolate that y. And this is 2 times y. So the inverse would be to divide everything by 2. So here you don't get the same thing. This one, you would do the distributive property, and you would end up getting the same slope. So your answer here is A, B, and D. All right, next we have a word problem. Xavier is considering 2 lawn care services. Premier Landscaping charges $15 for travel to Xavier's house and $55 per hour for maintaining his lawn. So I have that equation. And then Ace Landscaping does not have a travel fee, but charges $65 for lawn service per hour. Always stop and think, what are your X and your Y? What do they stand for, represent? And our X is hours, because like it's $55 per hour, $65 per hour. And then Y's the total cost. Now then it asks in B, it doesn't want you to solve it. It says, without solving this system, explain what the solution represents. So when you find the answer and you get your X and Y, well, what does that mean? The solution is the number of hours the landscapers would work when both companies would cost the same. So that point, when you graph both of these, that's when you're finding out when each company would cost exactly the same. Below that amount, Ace would cost less because it doesn't have this fee to travel. Above the answer, where they intersect, the better deal would be Premier because it's less per hour. Okay, let's go down to number 11. Number 11 is when you just want to solve a system of equations. One of them already has the variable isolated. That's step 1. So therefore, what I did was, in the other equation, in place of the y, I substituted what y was equal to, which is 5x minus 7. That's here. Then I followed the steps for solving a multi-step equation. And that would be to do the distributive property, watch those signs, then you want to combine like terms, and then inverse of adding or subtracting, and inverse of multiplication or division. And that gives me x is 2. So over here for x, I marked 2. Alright, then you can go to either equation, and in place of x, substitute in a 2. So 5 times 2 is 10, 10 minus 7 gives you 3. All right, let's look at the last page, and here we go. The first one, the same thing. We have the same thing going on here, where we're going to identify what our X and our Y stands for, and we're going to come up with our equations. Here we go. An online video streaming service offers 2 plans for unlimited streaming. Plan A has a one-time $25 membership fee and then $8 per month. Plan B has a $5 membership fee and then $12 per month. Okay, then it says, for which months is Plan A the less expensive option? For which months is Plan B? Well, first you have to find at what point do they cost the same. So you have to solve using systems of equations. Okay, so we need to take these equations. The first step is to isolate a variable. Well, they both have a y isolated. So I just took what y was equal to, and I put it right here in front of that. So I come up with my new equation. The first step then is to get all of the variables on the same side. And then I did the inverse of adding, which is subtracting, and the inverse of multiplication. You always do the inverse of the adding, subtracting, and the inverse of multiplication and division on the side that has the variable. Okay, so now x is 5, so the number of months is 5. And then if you wanted to plug it into either equation, you could find out how much it cost. And it would be $65 for 5 months with either a company. All right. Now, to determine which one is less expensive when, you have to look back at your first equations. This one costs less per month. So that means it would be less after the 5 months. This one would be less before the 5 months because it doesn't have as much of an initial value. It is a little more every month, but it doesn't have that big initial value. If you were only going to be with them for 2 months, you wouldn't want to pay that much and then $8 a month. You would want to go with that one. So your answers are Plan A is less expensive after 5 months, and Plan B is less expensive before 5 months. And another way you could even try this, if you wanted to, is take, let's say, 2, plug 2 into this equation, and plug 2 into this equation, and see which one has a better deal. So if you use this company for 2 months, how much would it cost? And if you use this company for 2 months, how much would it cost? Since X is the months. And that would help you also in determining this part. Which is kind of what I did here. It said, if the membership fee for Plan B is dropped, how does that change your answer to Part B? Well, I just kind of went through and redid this problem and took out that $5 and found that they'd be the same cost at about 6 1/4 months. They would be the same cost. So Plan B would be a better deal for a little over a month longer. So longer than 5 months, it'd be at 6 months. Okay. And the last one, number 13. Okay, Callie has a new kitten. The kitten weighs 3 pounds, less than half the weight of Callie's cat. Together, the cat and the kitten weigh 18 pounds. Which system of equations could be used to find the weight of each animal? Okay, well, I see my variables here are X and Y. So I put X and Y. And then it's talking about the weight of the cat and the weight of the kitten. So I made X the cat and Y the kitten. Well, then I read this first equation that I underlined in green. The kitten weighs, so Y is the kitten, 3 pounds less than half the weight of the cat. So that gave me that equation. Then together, the cat and the kitten weigh 18 pounds. So I added those equal 18. Well, each of the second equations has Y equals. So I wanted to change this equation to Y equals. So I subtracted X from both sides. And when I did that, I got these two equations, which was answer C.